For some, the intermediate bulk container represents the unknown. When it's used to store flammable and combustible liquids, what can fire professionals expect from it? Will its large size and plastic or composite construction negatively affect its performance in a fire? Do differently constructed IBCs perform differently? Can sprinkler systems provide a reasonable level of safety? In search of answers to those questions, this video reports on the design, manufacture, and testing of IBCs, especially extensive fire performance testing. Currently, IBCs are widely used for shipping and storing chemicals, and are recognized for these uses by many national and international codes and regulations. They're designed to protect personnel and property, even when filled with flammable and combustible liquids. Specific design characteristics may include thicker materials and protective features such as foam fill, and special single or multi-layer plastic construction. Other protective features include a fire protective blanket and a metal overlay or panels, or a structure of metal. All these design characteristics contribute to an IBC's fire integrity. IBCs are manufactured from resin that is heated and molded to form a solid, seamless container wall. The manufacturer may use the rotational or rotomolding process or the blow molding process. However, regardless of the process used, all UN-marked IBCs are manufactured according to strict quality assurance procedures and testing. IBCs are tested according to the Department of Transportation's stringent performance testing criteria. As a result, these containers have demonstrated their stacking strength and abuse resistance many times over. IBCs have also been extensively tested for fire performance under demanding real-world conditions. An all-encompassing fire test project gathered 24 designs from more than 15 manufacturers and subjected them to one of the most extensive fire test programs ever. Through these tests, IBCs have demonstrated the ability to withstand fire exposure and avoid jeopardizing properly protected storage facilities. In the tests that follow, IBCs protected their contents long enough for normal fire brigade or fire department response, and often longer. Fire performance testing was performed by Underwriters Laboratories, an independent third-party internationally recognized fire testing laboratory. Their work was done under the auspices of the National Fire Protection Research Foundation, which assembled an experienced and knowledgeable team made up of fire protection engineers, insurance industry representatives, fire code officials, and IBC users and manufacturers. The team developed the test criteria and guided the testing on scene for maximum effect and learning potential, with an eye toward developing future standardized tests. Additional guidance and direction was provided by Hughes Associates, a professional fire protection engineering organization. International support came from European fire protection bodies such as the Swiss Fire Institute and Sweden's Brandforsk. And members of the Rigid Intermediate Bulk Container Association, or RIBCA, provided containers for testing. The selected containers were real-world IBCs currently marketed by RIBCA members. The tests were based on two assumptions. First, fire will occur. Second, using properly designed fire protection systems, the IBC packaging should retain its liquid contents for a reasonable length of time and avoid pressure buildup. IBCs that can perform based on both these assumptions will not introduce added risk in a facility that is suitable for storing flammable and combustible liquids. The tests were also based on clearly defined parameters. They were conducted in a room with 30-foot ceilings. When IBCs were stacked, they were stacked too high. Representative IBCs included both rotomolded and blow-molded types, and rigid plastic and composite designs. Their DOT shipping designations were UN 31H1 for all plastic units and UN31HA1 and UN31HH1 for all composite units of plastic and steel. Fire professionals relied on established techniques used to evaluate other large containers, conducting intermediate and large-scale tests on those representative IBCs. These tests are designed to simulate a real-world exposure. The IBC testing was divided into 4 phases. Phase 1A began the process with unprotected scoping fire tests. The objective? Expose IBCs to liquid hydrocarbon pool fires and identify failure mechanisms and time to failure. Despite the lack of sprinkler protection, the contents of most units remained below 85 degrees Fahrenheit. In addition, the IBC's characteristics provided inherent resistance to pressure buildup. Valve mechanisms did not fail. Rapid, catastrophic failure was infrequent. Instead, the most common failure modes were small leaks below the level of the liquid where plastic was in contact with hot metal. In addition, there was some holing in the ullage area. Overall, the time to some form of failure ranged from 1.5 minutes to over 20 minutes. The longer failure times were achieved by containers with thicker walls and those with metal panels, steel support frames, or blanket shields. In fact, in these and later tests, most support structures maintained their structural integrity. Then, in Phase 1B, suppression scoping tests were performed with a required delivered density apparatus. These tests indicated that times to failure could be extended by cooling the container with water. Phase 2A took the testing to the next level. Evaluate representative IBCs in an actual warehouse scenario, arranged in an array 2 units long by 2 units wide by 2 units high. The objective? Determine whether a fire protection system would enable certain IBC designs and arrays to endure a 30-minute exposure without leaking their liquid contents. The fire scenario was established by igniting a 10-gallon heptane floor spill in the middle of a stack of IBCs. Then the fire was fed by a continuous heptane fuel flow at 2 gallons per minute for 30 minutes. This simulated the threat that would result if the tine of a forklift accidentally pierced a unit. Then came Phase 2B, which tested scaled-up arrays and evaluated units containing actual flammable liquids. First, representative tests were conducted on filled IBCs containing a Class 1B flammable liquid, heptane, floating on top of water. The objective? Assess how the containers react when used to store flammable or combustible liquids. Then a special test was run on a 400-gallon capacity IBC, half filled with 45 gallons of heptane floating on water. The results were the same, indicating that the material in the IBC does not change the results of the tests. In both Phase 2A and 2B, the fire's heat usually triggered the fire protection system in less than 1 minute. The sprinkler discharge ranged from 0.6 and 0.45 gallons per minute per square foot. The results? With properly designed sprinkler protection, many IBC designs were able to withstand a severe fire exposure for 30 minutes without failure. Both stacked arrays and unstacked IBCs were tested. During testing, adjacent target stacks did not become involved in the fires. Testers also wanted to know if a small array of IBCs would react differently to full-face fire exposure versus a nested fire. No significant differences were observed between face fire exposure and nested fire exposure. In the large array tests, several IBCs remained intact and structurally stable. The inside pressure did not rise significantly. Ceilings and structural steel remained well below critical values. Based on the results of those intermediate and large-scale tests, standardized fire tests were developed for eventual use in an approval process. Standardized testing allows containers to be evaluated to the same degree as in intermediate and large-scale tests while using fewer units in a smaller environment. Modifications to the designs of the sprinkler and exposure fire resulted in a standardized test that was more intense than the large-scale tests. Then experts established a correlation that allows the results of large-scale tests to be compared with standardized tests. That concluded the test program. The professionals involved in the fire test program developed conclusions that answer the questions that began this report. First, fire testing demonstrated that a wide variety of IBCs can be properly protected using systems already recognized for use with flammable liquids. Second, in a fire, an IBC's large size and plastic or composite construction in most cases will not negatively affect the performance of an adequately designed fire protection system. Third, IBCs do perform differently. Thick-walled IBCs and those shielded with metal panels or steel supports require no additional shielding. Thin-walled IBCs without metal panels can be shielded with a fiberglass foil-wrap blanket or by other means. And finally, properly designed sprinkler systems are highly effective with IBCs. These containers, even with flammable liquid contents, did not overwhelm fire protection devices during the 30-minute duration of testing. These answers indicate properly designed fire protection criteria could be sufficient to protect a number of polyethylene IBCs. Based on the test data and engineering analysis, the testing team concluded that many flammable and combustible liquids can be safely stored in these IBCs when they are protected by appropriate fire suppression systems. IBCs suitable for storing flammable and combustible liquids should be specially identified and marked. One mark would indicate special fire resistancy, and one would indicate compliance with DOT and UN specifications. In addition, an ongoing certification process to maintain reliability is being recommended. This certification process would identify IBCs that undergo a specified fire test evaluation. Over the course of fire testing by the National Fire Protection Research Foundation and Hughes Associates at Underwriters Laboratories, intermediate bulk containers demonstrated the ability to survive comprehensive fire testing. For further study, extensive background data is available from the National Fire Protection Research Foundation.